Hi everybody, it's Miss Austin. I'm here to go over the lesson 3 practice problems. All right. It says select all points where relative minimum values occur on this polynomial function. A relative min, if you were here for the recap or you look at the summary page, it says since graphs of polynomials can curve up and down multiple times, they can have points that are higher or lower than the rest of the points around them. These points are relative max or mins. So a relative min, that's lower than the most around. And then here, that's lower than the most around. So B and E. Number 2, add one term to the polynomial expression to make it a 22nd degree polynomial. The degree is determined by the highest power. So in order for this to be a 22nd degree polynomial, it has to have a term in it that has x to the 22nd power. So all I need to do is add one thing in front. You can put any number with it you want. You don't even have to put a number. I'm going to put Miss Austin's favorite number, 817 times x to the 22nd plus, now I'm going to write the rest of it. Before I did this problem was a 19th degree problem because 19 was the highest exponent. I just turned it into a 22nd degree polynomial. You don't even need the number in front, right? You can have any constant you want. As long as you have x to the 22nd power, it is now a 22nd degree polynomial. Number 3, identify the degree, the leading coefficient, and constant value. All right. The degree, I'm going to make a little chart. Degree, leading coefficient. Might have dropped the ball on not talking about that on the summary. The leading coefficient is exactly what it sounds like. Lead, like you're the line leader, you're in front. Coefficient is a fancy way of saying number. So the number in front of the polynomial. And how do you know which one? Because it's whichever one is in front of the highest powered. So let's scan. Yep, third degree. Leading coefficient is the number in front. We'll look in front there. What number's there? There's a 1 there, ninja 1. And the constant, a constant is a number without a variable. So 8. All right, next one. Degree, highest power is a 4. What's the number, the line leader, right? 2. And what's the constant, the number with no variable? 1. Last one. Ooh, this one was a little tricky. They did it out of order. Look, there's a 4th degree, right? And so technically, the leading coefficient is the number in front of the highest power. So I'm going to rewrite it for myself. That's the leading coefficient. And then what's the constant? The one without a variable. Don't forget to take that negative with it, negative 4.4. We want to make an open top box. Oh my gosh, here it is again, that open top box problem. It's not going away, my friends. We're going to cut out the corners of a square piece of paper. The cardboard is 9 by 9. I can't tell you, if you understand this problem, it's not that hard, right? You're cutting out corners of a piece of paper. This time it's a 9 by 9. Right? And this is called X. So if you cut out X and X, the dimension is going to be 9 take away 2 X's. What about this one? This is also going to be 9 take away 2 X's. And then when you fold those cuts up, right? If you watched me do it in the recap, that's your height. The only thing that changes on this problem is the size of the paper. if you've been doing these problems every day, those are the only two numbers that change. You're always subtracting 2 cuts from each dimension. What is the volume of the box when x is 1? Let's put a 1 in. 1 times 9 minus 2 times 1 times 9 minus 2 times 1. I know some of you don't have to write it all out, but I'm gonna. 9 minus 2, that makes a 7. So hang on. So this is 1 times 7 times 7, which is 49 cubic inches. What is a reasonable domain? Well, I can, I don't have to start with a cutout of 1. I could do 0.1. So basically 0, right? That's my lower bound. I'm not going to actually not make a cut all the way up to, well, if I did more than 4.5, right? Because I'm going to take away 2 of these. So 4.5 is the most I could cut, and then the paper wouldn't have any dimension. Number 3, or 5. Consider the polynomial. Evaluate the function at -3. So wherever I see x, I'm going to put in a -3. I'm going to do this with my noggin. You could use a calculator. All right, 7 times -3 times -3 times -3 is -27. Minus 2 times, that's 9. That makes -9 plus 10. I don't know what 27 times 7 is off the top of my head. So it's -189 minus 18 minus 9 plus 10. All right. Enough. Let's see. -189 minus 18 minus 9 plus 10. I got -206. I'm going to do the whole thing again just in case. All right. Got a job still. We done? One more. An open top box is formed, here's that problem again, out of an 11 by 17 piece of paper. Yada, yada, yada. Here's the volume again, right? That's the only thing that changed. I mean, yeah, they put the X at the end, but you can put the X, you can put these in any order you want. Right? This is just 3 dimensions being multiplied together. You could put this X in between these two, technically, if you wanted, like this. That's still something times something times something. Oh, but what do they want us to do? Multiply it out. Okay, this is great practice. So I'm going to do the box method, okay? Because I have to make sure 17 gets multiplied by both of those and -2 gets multiplied by both those. Then when I get that answer, I have to times all of that by x. So I'm going to make a box. It just helps you organize your thinking. So I'm doing 17 minus 2x times 11 minus 2x. All right, so now I'm going to do 11 times 17 and put the answer in there. So 187, 11 times -2x is -22x. -2x times 17, -34x. -2x times -2x, +4x squared. These two can get put together, so I have 4x squared minus 56x plus 187. Now I still have to times that whole thing, right? We did these two. Now I got to times this whole thing by x. So each of those, so 4x to the third minus 56x squared plus 187x. All right, I believe that's a wrap. I hope that helped. I'll see you soon.